Hi there. We're going to take a look at valence electrons and Lewis symbols. And our Lewis symbols are models that we use to discuss and represent valence electrons. So let's remind ourselves what valence electrons are. Valence electrons are the electrons that engage in chemistry. So chemists really care about them. And valence electrons are also the electrons that are in the highest energy levels. These are the electrons that are furthest from the nucleus and easiest to pull away or to disengage from the nuclear pull. So let's take a look at two electron configurations. If we look at first sodium, which has 11 electrons, here is its electron configuration, and we look for the highest energy level or the highest shell, which is 3. There's 1 electron in the third shell, so sodium has 1 valence electron. We look at oxygen, which has 8 electrons. Here is its electron configuration, and the highest shell is 2. And there are a total of 6 electrons in the second shell. So oxygen has 6 valence electrons. Now, you actually don't have to write out the electron configuration every time you want to figure out how many valence electrons an atom has. The periodic table is actually set up to help us out. Every atom in the first column, or the 1A family, has 1 valence electron. Every atom in the second family, 2 valence electrons. Every member of a given family, or a given column, is always going to have the same number of valence electrons. Now, we're not going to count, well, I shouldn't say count, we're not going to consider the transition metals. We're really not going to use those. We could count the number of valence electrons they have, but we're just not going to. We're going to be concerned with the main group elements, which are the S and the P block. So we're going to kind of ignore the transition metals or the D block and count over to the P block, ignoring the D block. So 1, 2, 3. Every member of this column has 3 valence electrons, 4, 5, 6, 7, 8. So pretty easy peasy. The only thing you need to remember is that helium only has 2 valence electrons. It only has 2 electrons total. So it is the only member of this family that does not have 8 valence electrons. So don't be tricked by that. Alright, now let's look at Lewis symbols. So what Lewis symbols are a way of looking pretty clearly at the valence electrons without having to draw an electron configuration. And what a Lewis symbol does is it uses dots to represent valence electrons. So it doesn't really matter where that dot is. It can be on the right, on the left, it can be on the top, on the bottom. But if there's 1 valence electron, it's going to be 1 dot. 2 valence electrons, 2 dots. And in general, as we distribute our dots around an elemental symbol, we want to kind of draw or have our dots at 90-degree angles from one another. So we see here beryllium, they're 180, magnesium, this family, they're all 180. They could be 90. You can have one on the top, one on the side. And then we look at boron, these are in the family, they're all 90 degrees apart from one another. And then carbon, they're all 90 degrees. So we kind of make the sort of box around each elemental symbol with our dots. And then after 4, we just start pairing, and it doesn't matter where you start to pair. This graphic starts pairing at the top, but you could pair at the left or the right or the bottom, it doesn't matter. And so we pair our dots until we get a total of 8, and that's the maximum number of valence electrons that our main group elements are going to have. And of course, helium can only have 2. So this is just a simple way to represent the valence electrons for a given atom. Now, you'll also be required to draw the Lewis symbol for a monoatomic ion. And remember, a monoatomic ion is an atom that has either lost an electron, so it has a positive charge, or lost more than 1, 2, 3, or an atom that has gained electrons, 1 or 2 or 3, and so it has a negative charge. So let's look at the Lewis symbol for monoatomic ions. And I have chosen sodium and sodium plus. So if we look at the Lewis symbol for sodium atom, there's 1 valence electron, so 1 dot. The sodium ion has lost that electron. It only has 10 electrons. It has the same electron configuration as neon. So it essentially has no valence electrons anymore. So the way that we draw that is we put our sodium in brackets, which means that it is an ion, and we put our charge in the upper right hand corner, and there are no dots because sodium has lost its only valence electron. Now oxygen, if we look at its electron configuration for the atom, here it is right here, and we see that there are 6 valence electrons, and here is the Lewis symbol for the oxygen atom. Now the oxide anion has 10 electrons. Oxygen has gained 2 electrons to get this filled S&P subshell, which is the same electron configuration as neon. Now in this case, it now has 8 valence electrons. Unlike sodium, which lost its valence electron, oxygen actually gained more valence electrons. So its symbol will now have 8 electrons around it. And again, we still put the brackets around our ion and then the charge in the upper right hand corner.